Hello students, I am Ashish Valuskar, Associate Professor, ISR IPSA Academy Indore. Today I am going to start practical based on digital electronics and mainly logic gates. So as you all of you know that the digital electronics basically based on 0 and 1, and the basic building block of digital electronics is logic gates. And the practical which we start or which we perform today is based on this logic gates, and from these logic gates practical we will start practical series based on digital electronics. The first base of digital electronics is logic gates. Okay. Here basically, as you know that digital electronics is based on 0 and 1. 0, if we talk about 0, it means it is 0 volt, and 1 it means it is 5 volt, or you can say high voltage. If we talk about, or if we say it is any logical statement, so 0 means false and 1 means true. If we talk about a switch, so 0 means off and 1 means on. It means that any digital electronics or any device of digital electronics based on these two levels, high and low level or low and high level, means 0 means low level and 1 means high level. Or you can say, if we talk about a level, a logic level, it is low and it is high. So all our practicals based on these levels only and based on this digital electronics. So 0 volt it is a low voltage, 5 volt it means it is high voltage, and two numbers we used, we called as binary numbers. These are binary number, 0 and 1. 0 means low, 1 means high. Okay. So our practical logic gates based on this. Now I will show you a slide and explain each slide one by one. So here you can see a series of basic logic gates: NOT, AND, OR, NAND, NOR and XOR. So basically these are the number of gates which we have seen over here and their symbols. Now we will start with basic logic gates. So there are basically three basic logic gates. First is AND gate, second one is OR and NOT. AND gate, OR gate and NOT gate. As you seen, it is on the screen that the PPT, the AND gate symbol is like this, OR gate symbol is like this, and NOT gate symbol is like this. And here there are inputs A and B, and this is output. A and B input, this is output A, and this is output Y. So output will be for AND gate is A dot B, for this it is A plus B, and this is A inversion or A naught, like this. So you see, this is the input and this is the output. Clear? In the if you see the input basically nothing but they are the signals. A and B, these two are the signals. It means a 0 and 1 will flow. 0 and 1 will flow. It means a high or low voltage will flow using this signal. This is nothing but this is a wire. These two are the input wires and this is the output wire. You can see Y, or you can also say it is C, A dot B, or C is equal to A plus B output. Any output you can take, is equal to A bar. So it is output will be C is equal to A dot B. It means here it will perform in AND gate dot operation. Dot operation will perform over here, and you can see a truth table. Truth table, it shows how actually, means what happening inside this gate. This will show you by a truth table. Truth table basically shown in here, means first if we make a truth table of, first we see AND gate. So A and B, two inputs, and this is output. This is output and this is input. So only two inputs you can apply, either 0 and 1. So if we apply two inputs, it means number of possible combinations are there 4, because we apply the formula 2 to the power n. So inputs are 2, so it is 2 to the power 2 is equal to 4. So there are 4 possible combinations, that either both are 0, or A is 0, B is 1, or A is 1, B is 0, and both are 1. So dot operation will perform in this AND gate, and inside this it is nothing 0 and 1. You just it must be clear that these two are the signals. Signals, it means when we perform the practical, you will come to know that what it means. These are the signals. They are nothing but there is the wire here, again a output wire, and where you will get the output voltage. 0 0, it means you are applying 0 volt to this gate, and 0 1, it means you are applying 0 volt to one input, 1 volt to another input, or high voltage to another input. So based on the truth table, you will see the output, it is 0.0 will be 0, 0.1 is again 0, 1.0 is 0, and 1.1 is 1. As you see in truth table also, you will get the same truth table, that 1.1 is 1. It means you will get, when you apply both high voltages at both the inputs, you will get high voltage. So it means that when both inputs are high, then only you will get the high voltage, and the expression will be C is equal to A dot B. Means apart from C, you can write Y or X, whatever it may be. Clear? So this is the truth table of AND gate. Similarly,